Okay, so this is a very long question on plane geometry, but it's not very, how I say, it's not very difficult if you break it down slowly. So I'm just going to show you how I approach it. So when I look at this question, they gave me a tangent. So the first part, they gave me a tangent. So my approach will be, okay, the first thing I saw would be the 90 degree. And I also saw a diameter, so there's also 90 degree. So mentally, I know that, okay, there is 90 degree here. And then they gave me same length. So they gave me same length. Okay, then after that, I'm supposed to prove isosceles triangle. So I'm supposed to prove the isosceles triangle. So whenever, I mean, to me, right, whenever I see I need to prove isosceles, I can either prove it through angles or I can either prove it through length. But it looks like it's not quite possible to prove it through angle because I don't have any angle. So actually I got more length information. So maybe I'm going to try doing it by length. And because the way it is given to me, because of the way it is given to me, I'm actually given two midpoint. So this is the midpoint of DG. This is the midpoint of AG. And actually O is also a midpoint. So because of this, right, it relates me to the idea of midpoint theorem. So if any one of you is like, okay, what exactly is midpoint theorem? So I'm going to put it at the corner here. So for the midpoint theorem, you need two conditions for the midpoint theorem. So you need two conditions. The first condition is the midpoint on the left. So the first condition is K is the midpoint on the left side. And then H is also the midpoint on the right side. So to me, I visualize it as the midpoint on the left and the midpoint on the right. So the theorem needs these two conditions. So with these two conditions, right, you got two results. The results will be KH is parallel to CB. And there's also another result. KH is actually half of CB. So in a way, right, this one is like 1 unit and then this one is 2 units. So that is the midpoint theorem. So this is the condition. Condition give you these results. So in another way, if let's say you got these results, you can imply the condition. So that is called the converse of midpoint theorem. Okay, so because of this, right, it actually get me the idea of midpoint theorem. So where is a midpoint theorem that I'm hoping to achieve right here? So can you see, right, O is the midpoint on the left side, B is the midpoint on the right side. So I got the two conditions for the midpoint theorem. So that means, right, this should be parallel to this. And because just now I know that there is a 90 degree here. So remember there's a 90 degree here. So the 90 degree came from radius perpendicular to tangent. And right now I got the parallel line. So that also implies a 90 degree here. So because of this is actually a perpendicular bisector. Perpendicular bisector of AD. And because it's a perpendicular bisector, these two will be equal. And that's how I get the isosceles triangle. So I did the actual writing already. So this is the flow and what makes me think of midpoint theorem. Okay, so that's the approach. And then the next one, right, is actually a Pythagoras. Why would I think of a Pythagoras? Because the way it is being formatted. You look at the AD square, the DF square. So actually, I try to find a triangle that can have a AD square. So I actually look around, because just now we also got a 90 degree here. That means, right, I can also do this. I can also do a Pythagoras. I can do a Pythagoras in this triangle. I can get an AD square. I can also do a Pythagoras in this triangle. And I also get an AD square. So which one will I choose, right? I'll choose the red color one, because the red color can give me a DF, can give me an AD. So I will choose the red color. So that's my approach. I mean, I got 290 degree. So which one can I do my Pythagoras? So I got to weigh out and see which is the one that can lead me to this expression. I wouldn't know until I play around with it. But because of AD square, because of DF square, I will actually use a red one to do my Pythagoras theorem. So if I do my Pythagoras theorem, it looks like this. It's AD square plus DF square equal to AF square. Okay, but if I do this, right, I will have a weird AF here. Correct? Okay, and I couldn't be using this part. So I might change my right angle triangle. I will change. Maybe I'm going to change to the bigger one. Later, I can use the same length. So after playing, that's how I play around with it. I wouldn't know as well. So when I approach a plane geometry question, there's a lot of playing around. So after this, I'm going to think. So I'm going to restructure this part. So maybe it becomes a DG square equal to a AG square. Okay, I can squeeze in my DF because these two are supposed to be the same. So in actual fact, the DG can be changed to 2DF. And then AG, right, this part is also supposed to be the same. I can also change AG to 2AB. Okay, so if you take a look, I'm trying to do the changing. So after I do the changing, right, this is what I got done. Okay, after that, let's observe. Let's observe what you have. Okay, I have my AD, I have my DF, but I don't have my DB. Right? So where is the DB? So do you remember just now you already proved that AB is the same as BD. So this part is actually the same as BD. Where do you get it from? From the isosceles triangle. So all in all, I'm gonna get quite close to the proof already. So I got a 4DF square and become a 4BD square. And I divide by 4 throughout. And I just bring it over. So I gotten exactly the same thing. So it starts off from the Pythagoras theorem. And of course, the Pythagoras theorem is even a choice. There's a choice with 3 right angle triangle. So you got to choose. So I choose the one that I can make use of the same length. And then I twisted the length because I also got part 1 to help me. So that's how I eventually prove it. I did the actual writing already. You can refer to the actual writing. The actual writing is exactly what I explained. Okay, and then the subsequent one is to prove similar triangle. Similar triangle, I think is easy. So I'm just going to erase all first so that it's easier. Okay, so the similar triangle, ADF is this big one, which I know that there's already a 90 degree. Then part 3, DCF is this one. So DCF is this one. So there is a angle in a semicircle. So this part will be angles on the straight line. So I also got a 90 degree already. And then, so I got a pair of 90 and I got a common angle. So that will be sufficient to prove the, what we call the similar triangle. Okay, so I won't be writing it out. It's already in the worked out answer. So how would you approach after this? So obviously when it's similar already, no matter what, try to write out the ratio. So scribble around your ratio. Hopefully you can try to get this. So I'm going to scribble out. So after I scribble out, what am I writing? After I scribble out the 3 ratio, okay, so did I scribble correctly? DF, CF, AF, DF. Yep, correct. So I have so if you take a look, right, it seems like I have the AF, I have the CF, but I'm not getting this part. So never mind, I'm just going to cross multiply. I'm just going to cross multiply first. Okay, so sorry, I write wrongly. So I cross multiply, I got my AF and CF. But why is this not GF? So where can I get it from? So do you remember the very first part here? DF is equal to GF. So you are given that DF is equal to GF. So that's where I'm going to change. So I'm going to change the DF to GF because I know that they are supposed to be the same. So I prove it. So I prove it from the similar triangle, but I need to twist it with something that's given to me. So all in all, we just keep using back the same length that they give us. A bit brainless, a bit doesn't make sense. To me, it's like you just keep looking around. So the first time I look at it, okay, I'm not getting the GF score, but never mind. It has to come from a similar triangle. Okay, so look at the flow of it. So just now part 1 helped part 2. And then part 3 is something like on its own. Okay, and then this is how we flow the whole question.